Hello everyone. Welcome to Subnetting a Little Bit. In this episode we continue with elements of the subnet mask. We will briefly review the subnet mask. Examine the format of the subnet mask. The possible values of the subnet mask. Then we'll look at the /30 subnet mask. And finally, the /31 prefix length. As previously noted, the subnet mask is a 32-bit number. It is expressed using dotted decimal notation. It divides an IPv4 address into two parts: the network portion and the host portion. It is always a series of ones, followed by zeros. The subnet mask will always have one of the following formats: 255.x.0.0, 255.255.x.0, or 255.255.255.y. The only possible values for x and y are noted in the table. The binary equivalent for the values of x and y are shown in the rightmost column. This table shows all the possible values of the subnet mask using the format n.x.0.0, where the n represents 8 network bits. The binary values for x are shown, along with the CIDR notation. Again, notice the pattern of ones followed by zeros. The first entry is the native subnet mask for Class A addresses. Keep in mind, the terms native subnet mask and default subnet mask are synonymous. The other values are possible if you subnet a Class A address, such that it ends up with a CIDR value between /9 and /16. This table shows all the possible values of the subnet mask using the format n.n.x.0. By the way, in these cases we are not necessarily using uppercase n's to denote the native class of the address. We are simply indicating the bits in those octets are network bits. The first entry is the native subnet mask for Class B addresses. All of the other values are possible if you subnet a Class A or Class B address, such that it ends up with a CIDR value between /17 and /24. The third table shows all the possible values of the subnet mask using the format n.n.n.y. The first entry is the native subnet mask for Class C addresses. The next 6 values are possible if you subnet a Class A, Class B, or Class C address, such that it ends up with a CIDR value between /25 and /30. Notice how 255.255.255.254 cannot be used as a subnet mask because it does not make provision for usable addresses. We'll see why in a moment. The last address shown in the table is the limited broadcast address. When a device transmits a packet and specifies the limited broadcast address as the destination, all devices in the local area network will process the packet. However, a router will not, by default, forward this packet. Let's take a closer look at the /30 subnet mask. When we say the /30 subnet mask, we are referring to the subnet mask that corresponds to a prefix length of /30 in CIDR notation. The /30 subnet mask provides a total of 4 sequential addresses, namely the network address, 2 usable addresses, and the broadcast address. We will look at the details of subnetting later in the series. But for now, let's assume we subnet 192.168.1.0 to get a network address with a /30 subnet mask. The corresponding subnet address map is as shown. It has 30 network bits and 2 host bits. Recall the formula for the total number of addresses per subnet. It is 2 to the h. The formula for the total number of usable addresses per subnet is 2 to the h minus 2. Again, we subtract 2 because neither the network address nor the broadcast address can be assigned to a device. H represents the number of host bits in the subnet address map. Let's apply the formula. Since there are 2 host bits in the subnet address map, the value of H in both formulas is 2. Applying the total addresses formula, we end up with a total of 4 addresses. Applying the total number of usable addresses formula, we end up with 2 usable addresses. This confirms what we said previously regarding the number of addresses for the /30 subnet mask. Shown here are the 4 addresses for the first subnet, or network. Note how they are sequential, ranging from 0 to 3. For the second subnet, the range would be from 4 to 7. Applying the formulas to the /31 prefix length, we end up with a total of 2 addresses and a total of 0 usable addresses. This is why the /31 prefix length cannot be used as a subnet mask in a network address space, because it does not make provision for usable addresses. That's it for now. Thanks for watching. And remember, nothing worthwhile comes easy. So go forth and subnet a little bit.